for page 7 on the molecular portfolio, this is how it would look like. This N would have a bond with H, so that would be a donor. This H would have a bond with O, which would make it an acceptor. Same with this one, it's also an acceptor. And then O needs a H donor, so it's a H bond donor, as well as this O over here. This F is also an H bond donor since it would need H. And then this O is also a donor as well as this one up here. And lastly, this H would be bonded with an O, so it would be a H bond acceptor. So this is page 11.8 on the molecular portfolio, which is the hydrogen bonding with water. And this is the drug Mobic. And right now I'm showing how it's able to bond with water. So in total there are 9 hydrogen bonds with water, and 2 of those, which are hydrogen bond acceptors, they're both up here. And then the rest, which are down here, and then these are the only 2 at the top, oxygen and nitrogen. All those 7 ones are hydrogen bond donors. And then there's 2 that are left out, and both of those are sulfurs. 1, 2. Those aren't able to have a bond with water because it's not one of the molecules that are able to form a bond, and the only ones that are able to form are either F, O, and N. So S is not one of those choices, so therefore it's left alone. And the rest all have a bond, either as acceptors or donors. And that is the hydrogen bond with water with Mobic. Questions? So I made the prediction that Mobic would not be soluble with water, mostly because there are more non-polar portions than polar portions. So I thought that would make it difficult to dissolve in water because of the ratio of polar and non-polar. And when I was searching it up, there was other sources such as PubChem that said that it would basically be insoluble with water, but it would be like there would be a higher solubility in acids and bases than in water. So that is the solubility for Mobic. And lastly, for the last page, which is page 10 of the molecular portfolio, we have these 2 questions. So the first one is basically asking us to prepare the solution of the drug, and in this case my drug is Mobic, so we're going to prepare the solution for Mobic. So we're given these 2 numbers. So the first thing that we're going to have to do is find the amount of moles Mobic has. So first we're going to use 2.30 times 10 to the negative 2. And since it's molarity, it's basically mole over liter. And since this is a milliliter, you're going to have to convert that into liters. And I done it over here, so it's 0.0500 liter. And we're going to plug that in over here. And then they both have liters, so you're going to cancel both those out, which leaves you to just mole. So once you multiply that, you get 0.00115 mole of Mobic. And then you would have to use that to be able to find the grams of Mobic. So you would use that and start off like this. And you would plug in the number that we got on page 6 of the weight of the drug, and this is the weight of Mobic. So 351.414 grams of Mobic, and then you would divide that by 1 mole. You would cancel out that, and it leaves to 2 grams. And then once you calculate that, you get 0.4041, and then you would round that up, and you get 0.404 grams of Mobic. And then after you're done getting the grams of Mobic, you would basically weigh that on a balance. And once you're done weighing that on a balance, you would add that Mobic into a flask that's provided to you. And after you pour that into the flask, you would add the deionized water into the same flask, but you would only pour it until the flask reaches the 50 milliliter mark. So for the second problem on page 10, it's asking us for the milligrams of the drug. So we're gonna use this, and then we're gonna plug in some numbers. 3.0, that's given to us in the problem, and then multiply that by the 2.0 milliliter that's also given to us, and then we're gonna divide it by 100, which then we get 0.060 grams. And then we are going to use this grams, the grams that we got over here, which is basically the grams of Mobic, and then we're going to divide it by the 2.0 milliliter that's provided to us, and then we're going to multiply that by 100. And then once we are done calculating, it equals to 3.0%. And then you have to convert the grams into milligrams because it's asking for milligrams. So to do that, you would plug in this number, grams of Mobic, and then 1,000 milligram divided by 1 gram. You cancel out the units, which leaves us to just milligrams, and it gives us 60 milligrams of Mobic. So basically there are 60 milligrams of Mobic in the solution. Thank you.